These are the frequently asked questions for pre-calculus for section 4.5a1. Starting with number 9, it says describe the graph of the function in terms of the basic trigonometric function, and then locate the vertical asymptotes and graph two periods of the function. So we have y equals 2 cotangent of 2x. And when we describe it, that means basically tell what the 2's are responsible for. So this 2 is connected with the x, and whenever anything's connected with the x, we have to think it's the opposite of what we're seeing. Normally with 2 times x, we would think that that's going to be a horizontal stretch factor of 2, but it's actually the opposite. It is a horizontal shrink factor of 2. All right, now the one in the front is more straightforward. We see times 2 there. That is our vertical stretch factor of 2. That's our A value up there. All right, what else did they want? They want us to locate the vertical asymptotes and graph two periods of the graph. Well, that would be what we would do normally. So we notice this is cotangent, and cotangent has its asymptotes usually at 0 and pi before any phase shift or anything, and change of period. And then what we would do is we'd say, okay, well now we do have a change in there. We have a B value of 2. What's that going to do? Well, if we divide everything by 2, that's going to take us from 0 to pi over 2. So those are going to be our asymptotes. And now we need to leave some room right in the middle for our 0 to show up. So that's going to be at pi over 4. So a good increment to use for this one would be pi over 4. And let's see, how many did say they want us to do? Locate and graph two periods of the function, so that should do it. So we're going to go ahead and get our asymptote on at 0 at pi over 2 and negative pi over 2. And that has taken care of that 2. You know, by our change in period, that 2 is taken care of. But the other one was a vertical stretch. And like I said, we know that for cotangent, we're definitely getting a 0 right between those asymptotes, immediately in the center. And then when we look at cotangent, we have to remember cotangent is always decreasing. So with this one, we have to make sure it's decreasing, and we have to make sure that we're going to go through 2. And normally, without that 2 in there, we would go to the right one and up one when we're talking about these graphs. But this is cotangent. So with cotangent and thinking about this behavior, what we're going to have to do is go to the left one and up 2, and then to the right one and down 2, all because this is cotangent that needs to be decreasing, and it needs to have a vertical stretch factor of 2. So we have to think, which one is this? Is this tangent or cotangent? And then we have to stop and think, we need that vertical stretch of 2. That means for every movement that we make 1 unit to the right or left, we're going to go vertically 2 units. And that gives us the 2 periods that they want for that function. All right, it took a little time to get number 17 ready for us here. Made a quick sketch of what's going on with this, and of course just use the fact that the period is 1 pi. And then we need to go back and describe all of these behaviors that they want here. So they want domain, and the domain is everything but those vertical asymptotes. So we've got to describe what's going on with those, and we notice the asymptotes are at negative pi, 0, and pi, and we realize, well, those are multiples of pi. So we're going to use everything but multiples of pi, and we want to use integers for those multiples. So this is how we show that n is an integer, and we're not going to be using those points in the domain. Then they wanted range, and the range is going to be all reals. This is going up and down forever, so we put our interval for describing all reals. Continuity, well, these are continuous over their domain. And that means for each one of the periods that we see over here, let's say from 0 to pi, if you were to graph cotangent, you would see you don't have to lift your pencil up to make that happen. It's just one smooth move as you do that. Next on the list, increasing or decreasing behavior. This is decreasing for cotangent. Starts high, goes low. Symmetry. This one has odd symmetry, and we might want to actually describe that we understand that the negative's going to actually go to the front of our cotangent there because of that odd symmetry. Boundedness, well, this is not bounded. It's not bounded above or below, so it is not bounded. We don't get any local extremum. We don't have a highest point and a lowest point with this. Then they want to know about the asymptotes. Well, we really already talked about those when we did domain. It only has vertical asymptotes, and they are described as all of the multiples of pi. So basically we're going back to the domain, and we're going to take off the not equal to for the domain piece there. We don't have to bother with horizontal asymptotes because we don't have any. And then we don't need to bother with end behavior because remember, end behavior does not exist when we're talking about cotangent. So end behavior does not exist. All right, the next problems on the list, the reason that you're having trouble with them is because we have not covered these yet. So I'll have to get the assignments changed so this goes on the third day. In exercises 35 to 40, use a calculator to solve for x in the given interval. Now this you did in geometry, but it's been a while. So what we would have to do with this is make absolutely certain that the calculator is set in radians. And what we're giving you here, the tangent of x equals 1.3, is 1.3 radians. So what you need to do is find the angle that would give you 1.3 for its tangent. And to undo that, we use the inverse. So we're going to need to find that inverse tangent button on the calculator and plug in a 1.3. So it's second tangent and 1.3 and parentheses, enter. Oh, I didn't grab the parentheses, but that's okay because it gave me the right answer anyway. So 0.915. Now we want to make sure that that fits the interval that they had this in. And they wanted the interval to be from 0 to pi over 2. So from 0 to pi over 2 would be 0, and then figure out what pi divided by 2 is. And pi divided by 2, 3.14 divided by 2, 0.915 is definitely in here. So that would be our answer. The tangent of 0.915 equals 1.3. And there it is. So this is using the inverse keys is what this is about. So with 37, things get a little weird because we don't have an inverse cotangent button on the calculator. No, we don't, but we do have tangent. And that is what cotangent is. So you could slap a 1 under here, do a little cross multiplying, and divide both sides by that little negative 0.6. And this gives us that the tangent of x equals 1 divided by negative 0.6. Now we can use the inverse tangent key. Now that will work for this problem. So we need the inverse tangent of 1 over negative 0.6. And that's because that's what cotangent is. So let's go over here and punch in second inverse tangent. And we need 1 divided by negative 0.6. And that will get us what we're looking for. So enter. Negative 1.0 0.03037687. Well, that is definitely not between 3 pi over 2 and 2 pi. So I started thinking, how can I give them what they want here? Well, if we have a negative 1.03 blah, 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 that's down here. So it is in that interval, but they don't want it negative. So then you think, well, how could I get it to not be negative? Well, all the way around is 2 pi. So if we take 2 pi and we subtract our answer, then we'll have what we want. We'll have a positive value. So back to the good old calculator, and we want 2 times pi, and then we want to subtract our answer, but it's already negative, so we might put plus a negative or just put it in there as second answer and see what we get. And there it is, 5.253. That will meet their requirements. So the cotangent of 5.253 equals negative 0.6. So trying to get that into the correct quadrant is what we're doing. Like I said, we'll be doing this in class tomorrow, but I'll show you a few of these now. Number 40, this is, again, very similar. This one has the tangent of x equals 0.3. So we're going to need the inverse tangent of 0.3. And then once we get it, we want to see whether or not it is between 0 and 2 pi. So second inverse tangent of 0.3. And that gives us 0.2914567, etc., etc., etc. So here's what we want to do. We want to check and make sure that's between 0 and 2 pi, and it is. So our answer is 0.291, except when you go all the way around the unit circle, there are going to be two different spots where the tangent will be 0.3. So one of them is here at 0.291, blah, blah, blah. Positive, positive, positive. Positive, negative, negative. It's not in quadrant 2 because tangent would be negative. Negative, negative, positive. It's in quadrant 3. So we need to figure out this angle. Well, that's not going to be hard to do because these two are congruent. So if we just take pi plus the answer we just had, we'll get it. So let's go back and tell the calculator we want pi plus the answer we just put in. And there it is, 3.433, blah, blah, blah. So there is the other one. So the tangent of 0.291 will equal 0.3, and the tangent of 3.433 will equal 0.3. Now those are the only two, because if we finish putting those signs for the quadrants in there, and we see quadrant 4, tangent would be negative, and it needed to be positive. So that's it for these FAQ